Hello. So we left off. We're trying to make our exception and interrupt handler, and we're just trying to put it in the right place once the ROM loads. So we're using a DMA, and we kind of ended up with all of this stuff to kind of format and determine how the code lays out in both the ROM and in memory. But it started to get kind of messy, and we weren't getting quite what we wanted. We were getting uh, mostly down here in this Origin 1000. Once we did that, we weren't getting what we wanted. Now, I've thought about this actually for a couple of days as far as how I want to solve this. And my first thought is, let's brute force, let's write the code. And I thought really hard, and the Bass assembler has has some really cool functionality, and we really could push it and use some of the less common keywords that are available. But I think it'll complicate the code. I think that there's a very minimal benefit to it. And really, the end goal is to put this exception handler into its own blob, its own executable blob that could then be used by a C source file. And so that is the right answer. That's the direction that we are going to go. And so to do that, we're going to start and just make a new source file. Um, I'm just call it exception handler. I kind of want to put some interrupt bit in there, but it doesn't really matter. And this, once again, I'm kind of using the convention of the includes are for macros and constants, whereas .s is going to be an actual source code file that generates a binary output. So yes, I want to change that. And then let's see. So I'm going to go ahead and open this up, hit it with Notepad, and I'm going to go back and I'm going to actually create this, make a new text document. This is going to be a CMD, just so that we can compile it separately as well. And I think our process will turn around and call this one first. Oops. Yeah, so I'm going to open this up. All right, so let's start with move to other view. So this is Notepad++, so now I have a split screen. Really cool, really handy. And I'm going to copy over just the little bits that I need. So this, we're going to take this and copy that over, but we're going to change this. And we're going to make this a bin output. Again, it's just going to be a series of instructions. And we'll see this once it gets copied into place. So we're going to take this, but we're going to skip things like this. This is a fill to 1 megabyte. That means your minimum size is 1 megabyte. We don't want that. We don't need it. We're going to go ahead and take these, and so origin 00, that's in the output file itself. It's just going to start at position 0. And then the base address, when we are in the exception handler, will be this 8000 base address. So that's great. We are going to copy over this little include file, and that is, we've got that open over here. That's just our constants, a few of our common macros, but our register names are there. So really normal stuff. And we've already covered most of this. I'm just kind of going over this because I want it to be clear why we did not include some things. That's the difference that we're talking here. Okay. For example, we are not actually outputting a ROM with this source file, so we do not need the header. We also do not need the bootloader, because we're just outputting the exception handler instructions. Okay. And so now I'm going to come over here and I'm going to just take this stuff that's after the origin 1000. And I'm going to just grab everything to the end. Boom. And over there. So that means we don't need the, well, actually we're going to leave this, and I'll show you how we're going to use that. So this all looks good. Yeah, so the tick is considered to be a comment character in the .s files. But it's not in the ASMs. And I use the ASMs for the base of a ROM, of something that we can play, the whole program, whereas .s is just the assembly source code file. All right. So the first thing I'm going to do, I'm going to move this over to the other view here so that we can see that. And perfect, it opened up our make file. That honestly just got lucky. So again, I'm pointing out the things we don't need. We're not making a full ROM, so we don't need to do this checksum part. We're going to copy that over, and we still have to change the name. And so that's fine. But this is, and just double checking, ASM videos exceptions. This is the make command for just the exceptions. I am going to have it execute that. So that will do a fresh build of our exception handler blob every time we build our exceptions ROM. So let's kind of, we just moved a whole bunch of things. Probably should have done that a little more step by step, but let's kind of take it once, let's test it out. So first, we're going to go into the lib folder and just take a look, make sure everything's in here. And I'm going to do exception handler CMD. Source file not found. Oh, because we said that it was an ASM and it's actually an S. We do that again and it compiles. We have something. Let's take a quick look at what we got. And we're going to use our binary viewer here. And remember, we told it to create exception handler.bin. It is currently 1K in size. So we'll take a close look at that. And oh, it is actually our hex 400, which is 1K. Very exactly. Here, just to show. So hex 400 is 1024. So that is perfect, exactly what we were expecting. If we look here, we see that this first 4 bytes are different than the rest. Then also down here again at the 180 mark, and that should be, and we'll see this in a moment, when everything else is working like it should. That is the E return instruction at the 0 mark and the 180 after that. So that's great. Down here we've got our variable gap that the PIF puts in. So we're looking good on that. All right, so now we will move up 1 level and go to the exceptions folder and make that. Okay. What if I do that? Okay. But that was kind of a weird change, and I am going to see. Alright, that change is compatible for both things, basically. So, yeah, this is... Here, the reason I thought that this one was a little bit weird, I'm just going to kind of point it out. So, exception handler.cmd is the file that we're talking about right there. And so what we're telling it is to go up a directory and then back into the directory that you're in, which doesn't seem intuitive here, but that's actually what helps it work when it's being called from this other path. So that's saying go up a directory from the exceptions folder, then go into the lib folder and call the CMD. And then that in turn is saying go up a folder, then go into the lib folder, which is where you're at, and then compile that. So it's a little odd, but it totally works and it totally makes sense. I'm not going to get bogged down with that. But it was an easy fix, and I'm happy to have that. So we are in, let's see, I'm going to go back up and go to the exceptions folder. We have our make, and so I was expecting there to be 2 lines here of bass assembled, one for the exception handler call and one for the other. Okay, just once we get this right and done, then it will be much, much easier to work with. Okay, so all right, so there we got our B. /C. I didn't want to get that fancy, but okay. All right. That is more what I was expecting to see. So I'm not sure why, but when this command was being called, it was exiting before it would do the echo. So by doing the command C, it calls the command script, or it creates a new instance of the command prompt, calls exception handler.cmd. Once that finishes, it exits from that extra instance of the command prompt and comes back and finishes out our script. So that's okay. That will do what we want. And if we look here, what we've got is our DMA is unrecognized variables, really normal stuff. So this is working. I'm going to take out my really weird actually, I'm going to say echo exception handler. And then here, I'm going to say echo exception. Yeah. So now, and sorry, I want that to be a little bit more obvious. Okay, so it recognized these spaces. And here, I'm going to do another one. I think that will just give me a new blank line. Kind of. Yeah, so here I've got a blank line. It says exception handler, assembled in blah, exceptions, and here are my warnings. So now I can kind of see the difference between the two of those. And all right, so now I'm actually going to close that, and we're going to be doing so much work over here, but I'm going to move this back to the other view. There we go. So now we got a little more space to work with. All right, so the exceptions that we're seeing here are the compile errors. And so let's see, exception handler part 1. Yeah, so these are the values that we moved to the other exception handler blob. So we kind of have to, we got to figure this out. Okay. So the first thing that we're going to do is this is a binary blob, an executable blob, very similar to the N64 boot code. And so what we're going to do is we're going to say exception handler. And so this is, just like we talked about before, going up to the 1 megabyte mark in the ROM, and that is where it's going to insert this exception handler. That's great. So now, though, we need to we need some labels around it so that we can use this position in the DMA. So let's go with this. Okay. And I'm actually going to do those two. And all right, so this was a thing I was trying to get a little fancy, I guess. Okay. So start, end, and the destination. All right. So that is the start. Absolutely. This, they want the end. So for this, we are going to say that plus 0x300. So, and then we need our closing parens. So the exception handler plus the hex 300, that's going to take the first hex 300 bytes, 768 bytes based on that 400 we saw earlier, and that will be the end of that. So that's the first section, and then this one we're going to do very similar, and we're going to say plus 31, oh nope, 320, and hex, and then for now, so this is the end, and so right now it's 0x400 close paren. All right. So we still have the two DMA lines. They're skipping over that white space area that we have. In fact, I'm going to go over here. And remember that we've got these, but we have that last one that's not clearly labeled. All right. So I am going to compile that. Oh, I was focused. So that keyboard shortcut works and focuses on the file that is selected. And so in this case, it was our binary blob file, and it's looking for a make command. And in this case, in the lib folder, there is not a single make command. There's a make font that we have, but not a make. So that did not work. So I needed to be over here when I hit F6. And now they have both compiled. It may actually copy something up to RAM. Which is good. And we're going to get there. I feel the need to clean this up. I've got comments, I don't really need those pieces. Okay. And so that is fine. And let's see what happens. All right. Okay, so this is our new init code with a stack. And this is that first loop to say that the DMA is not busy. Now we're going to perform our DMA. And all right, so it doesn't look like it happened. And I was thinking about this as well. I think I was overthinking this one thing that I did the other day, and I feel kind of silly, but this was set to WR. And so again, focused on the wrong file. There we are. Yeah, I was thinking about it, and once again, that code was from Peter Lemon's repository, and I shouldn't have second guessed that. That was probably correct. Because it's not often that you actually want to write from RAM into the cart. So the default is really to read from the cart, which is what that code was originally doing. All right, I'm going to set this breakpoint there. Let that spin for a moment. So again, this is the check between the two DMA actions to see if the DMA is busy. And it's using the T0 register, so we can see that that value is a 1. I'm not positive that that's updating like it could. So I just by pressing the F10 or F11 keys, it'll go back into a step mode versus run mode, which is what we're doing here. So it is still showing that as a 1. Gonna let that run for a few more cycles. I'm not sure what the problem is there. Okay. So I did go ahead and launch the web browser. I'm going to pull up Peter Lemon's repository and just do some comparison. Make sure I didn't mess up that code. We'll go ahead and restore that. There was some good stuff up here. And okay. this will take us too far in, but okay. There is his DMA macro. So I'm going to resize. Great. And once again, I edited only one real piece of this, but it's not working like I would expect. Oh, to cart to RAM. So the to RAM one is the one we should be using. Let's double check that. That is the one that's being used. Great. And that is the one that should match this DMA. DMA data, copy cart to DRAM. That's, yeah. All right, that's what we should be doing. So A0 PI base, LW PI status, pretty much what we were expecting there. BNEZ. So this is a BAS syntax. I think GAS has something very similar to the GCC assembler. Basically, this is saying look for the last label behind me. And so look for this location and branch there if the condition matches. Kind of an interesting syntax. There is a plus option here as well. And you can even do like +1, +2. I would tend to avoid going with the numbered versions. The first one, and especially in a very small loop like this, it makes sense. It keeps the code rather small. You don't need a lot of labels at that point. So here we have the T0, the destination, the 7F, PID RAM address, T0, A0, T0, 1000, start. Okay, so that all looks correct. So that was the difference between the RAM to cart and cart to RAM. So since I had that, I figured I'd make it right. Okay, well, we're still not getting what we expect here. Alright, so the thing here is we're really expecting this DMA to complete. It would be one kind of error if we weren't seeing the value in RAM back here, but we're not actually seeing the DMA complete. And that is what is bothering me. It attempts to start. So the values, what happens is the values are written to the special DMA location, register locations, hardware registers. And when you do that, it is setting the register value, the status value, to a 1, which is good, it makes sense, but it's not turning it back off. So, yeah, that is the part. So we can watch the count, and it's going up and up. I would really expect that to complete. And, you know, anytime you're working with an emulator, like, you try to think through your issues, like, did I write the right thing? Am I using the right values? And so you start there. But then the next question, is there a problem with the emulation? You know, is it not perfect in this way? And, and I don't know. I don't know. So that's my question. I don't know. Is this an emulation bug or a code bug? And because this is so low level, I don't have anything visual to indicate success on. If I had something visual, I would load the ROM up onto a flash cart and test on hardware, because that is the definitive. That tells you, does it work or not work. And yeah, like I said, I don't have enough in this ROM yet to make that a valuable exercise. So, all right. I hate to do this, but I am going to stop at this point. I'm going to do some offline research. I may run it in an alternative, in another emulator, and see if I have the same experience. And we'll go from there. Thank you for following along.